project about model building through linear regression and time series. So at the beginning here, we laid out some definitions. We described the assumptions we can make and which we have to test. Right here, we describe the statistics and variables we can use to see any significance level or any correlation in the data. Moving on, we did all the imports, and throughout this lab I used stat models just because it had a very comprehensive summary table. For the data frame, I saved that as df. I changed some data types just so they don't show up in the pair plots or describe, making it a little less time consuming. And I just used made a simpler data frame to use for the linear regression. I graphed that and looked for any relationship between any variable with price. So right here we can find that grade as well as square foot living had a very clear relationship. Used a .core function to find any correlations, and I graphed that using a heat map. So I used square foot living for the simpler linear regression. I had that in a scatter plot, and then I used stat models to see the summary of the data, which gave me the coefficients for the independent and the constant. I used these and I graphed it over the scatter plot, which gave me the linear regression. And I also predicted the values by creating another data frame. I fed that to the .predict, which gave me all these predictions. So they match up 1 to 1 basically, and I joined it inside another table. Moving on, for the multiple linear regression, I used square foot living and grade, and I saved that as x multi, which is a dependent variable for this multiple linear regression. I graphed that out, and I also used the stat models for the summary, which gave me the coefficients and all the helpful data right here. And I created another df just for making predictions using square feet and grade, and I fed that to the .predict. We used it to make future forecasts. At the beginning, we saved the US consumption.csv as a df. We changed the index, and we looped through the range function, and we looped through 1970 Q1 until 2019 Q2, and we used the quarters as a frequency. So each time it increments by a quarter. Time variable that we saved as the index, so we can use it later on. And because we did that, we dropped the quarter column. Right here we're just graphing, used pair plots. Right here we took consumption out and we saved it for the response. So here we kept all the rows. We cut the first column, which is consumption. Here we did the opposite thing, and we use AutoML tools in order to get the P, D, and Q variables, which we use later on in order to get all of this data. We also, right here, we're graphing to see if there's any autocorrelation between the residuals, and most what we used were inside of this shaded out area, so we're good to go. And here we tackled more assumptions. Here we graphed out the residuals over time, just a line plot. At the end here, we fitted all the data into a scatter plot. We used the fitted data and y, and we saw there's no trend in the graph, so we know we're good. Here we did all the graphs again. Here we looped through and we saved everything as a scenario. We put these as it's basically just for 4 quarters. If we increase that, we we can make more future predictions. But since we have 4x4 right here, we only did 4 quarters, which is basically a year. So this is the year we wanted to get, and we used a scenario that we saved above. And we graphed this to see our forecast, which basically does match what we expected.